Alright, so here we're going to look at performing wire repair and show you a few different tasks involved with that. We're going to demonstrate soldering, we're going to demonstrate how to use crimpable ends, and we're going to demonstrate how to use OEM crimpable ends like you might find on harnesses like you would have here. These OEM crimpable ends would go in a larger plastic connector. So we're going to start the process with soldering. This project is going to make sure you're proficient in all three of those skills. So what you want to begin with is you're going to cut a 10-inch piece of wire. So we have our wire here. We'll measure it out. Or sorry, not 10 inches. You're going to cut a 6-inch piece of wire. So here we're at 6 inches. Using wire cutters, we'll cut that off. The next step is going to be to strip the end of the wire to get it ready for soldering. We can actually strip both ends of this, and then later on we'll cut it in the middle and put those together. So in your packet it explains that when you strip the wire you want 1 inch of bare copper. So make sure you measure it. You can use a pair of wire strippers. There's a few different styles. We're going to use this one here. I'm going to measure out 1 inch roughly. Make sure you select the correct gauge. This happens to be 18 gauge wire. If you're not sure, you can always go one size larger, and if that doesn't strip it, then you can work your way down. But what you want to do is make sure that you're not pulling any of the strands of copper off when you strip it. Okay? So that's one end. We'll do our other end. And pull the coating off of the wire. Next, we're going to cut this wire in half. That's pretty easy to do. Just hold the ends together, figure out the middle, go back to our wire cutters, and now we have that cut in half. When we solder the wire, you're going to want to have these wires twisted together a little bit so they will hold each other. So we're going to put them in the middle. We'll give them a slight twist, not a heavy twist, but just enough that they will stay intact on their own. If they come apart, you may have to twist them further, but there you can see we have a pretty good twist. They're held together. The copper's overlapping. It's not extending and going over any of the insulation. A common mistake I see is sometimes people will put this on metal or a melting surface like rubber. You want to make sure you put it on a surface that's not going to absorb the heat. That's the problem with trying to do this on metal or on the back of a vise, but you don't want to put it on anything like rubber that's going to melt and now contaminate the joint. So I recommend a block of wood for doing the soldering. Now there's a few different soldering irons, and there's actually two types of solder we're going to talk about today. Either soldering iron will work. There's some key parts of it. You want to make sure the tip is clean. It should have a nice silver coating here. The tip is what they say to be tinned. And you want to make sure that this has good contact. Sometimes these soldering irons over time will take a long time to heat up. They should heat up in about 15 seconds, 20 seconds maximum. If it's not heating up in that amount of time, make sure you have a good contact with the tip. The tip should not be loose in here. Sometimes you will need to take this out. So this one uses an Allen key. So we can loosen these two set screws. And we can remove the replaceable tip. Now what will often happen is this tip may be loose, or it may get corroded. It might have black corrosion in there and not making a good electrical contact. So make sure that is clean. Also make sure those set screws are tight. Often because of the heat cycling they will loosen up. So you can put that back in. Make sure it's fully seated where it needs to be, and tighten the screws. This is a good step before you begin soldering to ensure that you don't have any problems. Remember, the soldering iron, you're just going to hold the tip against what you're soldering. It doesn't require great amounts of pressure. This one here, I'm not going to demonstrate removing the tip, but it has a set screw up top that you would loosen with a straight blade screwdriver. If you loosen that, this can pull out. It has two pins on the end. Same thing. They need to be tight, need to be cleaned properly. Now let's talk about our two types of solder. The first type I'll mention is acid core solder. We're using flux core solder when we do soldering, and this lead wire is hollow on the inside and it contains the flux. Acid core uses an acid. Now you want to be cautious and never use this with copper. that acid flux will continue to etch into the copper even after the soldering is complete. So you might be able to use it, you might get a good solder joint, but over time when that's put back in service, it will now begin to eat through, corrode that copper, and the wire will break. Before you decide that acid core solder is completely useless, what I do recommend it for is tinning the tip of these soldering irons. Rosin core will actually contaminate the tip. Over time they'll get dirty. Both of these we cleaned right prior to the video. But if you have a dirty tip, acid core actually is the best for cleaning that up. So keep it on hand, but only ever use it on the soldering iron, never on copper wire. Other applications, maybe soldering tin or a radiator, that might be an acceptable use, but not copper wire repair. So we'll set this aside. What we are going to use is rosin core solder, which uses a rosin flux in the center. And when we're soldering, hopefully you'll be able to notice that I'm going to be trying to touch this to the wire itself, not to the tip of the soldering iron. The soldering iron will contact the copper, this will contact the copper and melt into the joint. Also remember, when you're handling solder, it is lead. There are poison warnings on here. Obviously you want to wash your hands, you don't want to get it near anything that you're going to eat because lead is harmful. So we'll get set up here. I think I'm going to use this soldering iron. So we're going to plug it in. And get started. Alright, so we can see the light is lit on our soldering iron. That's a good indication. It proves that we have power. It should heat up in just a little bit. We'll see some smoke come off the tip, and we should see the solder that's on the tip, the tinning, turn to liquid. We're going to put that against the copper, and we're going to put our solder not on the tip, remember, but on the copper, and it should draw it in to the joint. And that's what we want to do. We need to make good contact, heat up the copper. Starting to go. And remember, that solder will actually be drawn towards the heat. So you want to apply enough there, but not too much that makes a ball. If we don't have solder anywhere, we can move the tip and use the heat to draw it towards itself. It's a good idea to roll it over, make sure both sides of the joint look good. I'm going to try and use the tip here to draw the solder back through to the far side. You can see some of it coming through. I'm going to add just a little more. And when we have a proper solder joint, it should look like it's just silver coated wire. You should see the individual strands, but it will look almost like it's frozen in ice, just a coating on there. So we're going to let this cool for a second, and then I'm going to hold it up so you can see what we have here. The wire is going to be warm because remember that soldering iron was heating up the entire copper, so be careful. If you hold on the insulation, it's not too bad, but I definitely feel some heat on this. And here you can see that we have a good connection, good solder joint between there, that I can see the strands, I can see the solder is definitely melted in between them thoroughly throughout the joint, so that's going to be a good solder joint. Okay. You will notice I have some dry strands over to this side. I don't know that I need to do anything to solder them, but I do want to pinch them so that they don't poke through our heat shrink, which is going to be our next step. So I'm going to use the pliers on these wire strippers and just pinch them down so they're not going to poke out of our heat shrink. We want to make sure that we protect this solder and wire from the environments, from corrosion and moisture. And one of the best ways to do that is to use heat shrink. So let me get our soldering iron out of the way. They have little stands here so you can protect what you're working on. You're going to select the right size heat shrink that it will just fit over the wire and the connection. Looks like this size should work. Make sure you don't put it on while the wire is still too warm or it'll start to shrink on you right away. You want to trim the heat shrink to the right length. Now remember, it will shrink in length a little, so you want a little extra, maybe a 1/4 inch on each side. So we're going to basically measure that out to what we want and just use scissors to cut the heat shrink. We can slide that onto our connection, onto our wire. Make sure it goes over the full joint. Get it centered, basically what you pre-measured for. And then we're going to use a heat gun to apply heat. This is going to blow hot air. There's two settings, a high and a low setting. Either one will work for our heat shrink. So let's plug this in. You want to make sure that you're not doing this with a flame. It's nice to use a heat gun that blows just hot air, because a flame can cause burning on here. It can burn the heat shrink. This is just going to shrink it down without any flame. So we'll turn this on, and you'll see this shrink down. There you can see you can actually see the steps in the joint and insulation because the heat shrunk tight around there. So that's now sealing and protecting our joint from the environments and insulating it to prevent any type of contact. So we're now done our soldering and our heat shrink. Let me unplug both of these tools. And now we're going to move on to our next step. And I think what we're going to do first is our solderless terminal. Now, there's a few different sizes of wire, and because of that, they have different solderless terminals available. The yellow terminals are the larger ones. They will typically do your 12 or 10 gauge wire. Blue might be this light color blue, like on nylon, or that's color blue there. Either one, they are meant for 14 to 16 gauge terminals, and our red are meant for 18, 20, sometimes even 22 gauge terminals or wire. So you want to select the right one for your wire. If you remember, I said this was 18 gauge, so it should use the pink or red terminals. We're going to strip the right amount for this. Now, you'll notice that on these terminals it has a stop. We're really looking for only about 1/4 inch of bare wire to make contact. That's not something I'd say you have to measure so much. You can probably estimate it. So you're going to strip just a small amount off the end there. Doesn't matter which end. There we have about 1/4 inch. You can straighten the strands if that's helpful. And try it out before you crimp it. Put it in there. Make sure that the insulation goes fully in. You don't want the copper to go out in the terminal area. This one has a nice stop. You can see the copper going through the barrel and stopping there. And the insulation is in the other part of the barrel, confirming that we have stripped the right length of wire. You're now going to want to use wire strippers and wire crimpers, terminal crimpers. And before I show you that, I want to talk about the fact that not all tools are made equally when it comes to the crimping portion of it. So we'll just set this here. Here you can see one set of crimpers. It uses the colored dots to indicate what type of non-insulated terminal. So we have our red and blue in the first section, our yellow for the other. But what you'll notice is this anvil part, notice these are all the way closed, it's very square. And when I crimp that down, it's going to give it a square, boxy-like crimp. It's not really biting down on it. These are not my favorite. I do not necessarily recommend these. I've seen sometimes these crimps pull apart. You can pull the end off of there. What I recommend is looking for a crimper that's going to kind of fold it down on itself. Now, remember, this side of this was wire strippers, but the handle portion is crimpers. Very similar. We have red in this section, yellow and blue here, but you can see how it has a half moon, and then it has a spike coming down, or maybe like a little hill. And when you push them together, you can see how that really crimps it tight and folds it around. I recommend looking for this style crimpers. There are other ones. This one here would be like a ratcheting mechanical crimper. It's going to do a nice job as well. It actually ratchets all the way shut to make sure you get tight enough before it opens up again. You select the right one for the correct terminal. But understand that a cheap crimper, or some are just poorly designed, do not do as good of a job. When you crimp this, try to have that little hill poking up on the bottom side. There's a split in that barrel. You want to have that split folded down and around. So we're going to turn this, try and let you see, have a good view here. You can see our barrel is down on the, our hill is down on the bottom side. So we're going to put our terminal in here. That's going to poke up from the bottom. Make sure I'm on the metal barrel portion of that. And then you're going to squeeze down basically as tight as you can. Use 2 hands, and that should crimp it. You really only have to do that once. It's going to poke down in. You might see a nice little indent there. Try and pull it off there. Try really hard. If you can't pull it off, that's confirmation it's a good crimp. If you can pull it off, well, something was wrong. Either you should have selected a better tool or it needed more pressure. So definitely give it a pull test right away. That is how you install a solderless terminal. Our next type of terminal we're going to put on the other end is the OEM terminal that we talked about, that would go in a plastic connector body. Very common on newer vehicles. With the multitude of electronics, you'll see these used quite a bit. By using this terminal, you can pull out the old pin or old terminal and slide the new wire connection right in and make a good connection. Now there's a few different styles. You'll see ones that use flat tabs. We have the female connection on this row, the male connections below them. This is often referred to as Metripack. We have the round ones where you'll have a round tube and a round pin that would slide in it. There's obviously different sizes. This style here is called Weatherpack, but there's a few other. Deutsch connector would be another round one. And here we have a small pin. I believe this is actually a Molex connector, very similar to our Metripack. You just want to make sure you're selecting the right terminal type for that connector. Each plastic body has its own design. In this case, I think what we're going to use is we'll do the Metripack one we have here. Actually, sorry, we'll do that one. You can take a look and you'll notice that we have, I'll put the wire in here, might give you a little contrast. We have what I like to call two sets of ears. The first set of ears, the ones that are in the middle, are meant to contact the copper. That's going to do our conducting. The back set of ears, the ones at the very end here, they are meant to wrap around the insulation and provide support. So we want to strip the wire just long enough that it will go through the conductive ears, which once again we're looking at basically a 1/4 inch. We don't want the copper to go out in this terminal because it will interfere with the pin sliding in it. When we are done, we can actually test and make sure that this pin will slide fully in. So we're going to strip the right amount. We're going to crimp those ears. And then we're actually going to solder this just to ensure good conductivity in that wire. So let's start with stripping off the right amount. Like last time, we will double check ourselves to make sure of the fit. We just need a very little bit, a 1/4 inch or maybe just under. And there you can see that sits in there nicely. Now these types of connectors require a different crimper. We're going to use this style crimper here. It has a few different shapes. When I close it up, you can see there's two round ones down at the bottom. Those are actually for the rear ears. They're not really biting into the insulation, they're wrapping around it. So we will use them at the end. The others are numbered. I don't think you can see it in the video, but there's 2, 3, and 4 right on the front here, and you'll select your size based on that. Now what I recommend is actually just taking the connector, putting it in there, and figuring out which size you want to use. I think for this one here, we're going to use the middle, which would be number 3. Those ears, they should wrap down and into the copper. So you'll notice that one part of this has a little point facing down. You want to make sure you're using that to wrap those ears down. So we can position this terminal right in the tool. I'll hold it up so you can see it again. And we can just squeeze it just a little, not to start crimping so much, just to hold it there, and we'll insert our wire in. So here you can see how we have that positioned, and that the ears are on the top and they're going to fold down. We're then going to take our wire, stick it in the right length, make sure our copper is directly under the ears we want, and then crimp it down. Notice I'm holding the base of this on the table. That gives me a nice ability to push and crimp down on it. It's actually pushing rather hard. There we go. And we'll crimp that down tight. Might have to pull it out of the tool. But here you can see we just folded those ears over. You can see them wrapped down and pinching the copper. The back ears are still standing up. And we want to leave them like that until after we solder it. We don't want to heat it up and solder it and have those back ears melt into the insulation. So we're now ready to get our soldering iron again and apply a little bit, just a small bit of solder here. Same thing, we don't want our solder to fill the connector. So let's plug in our soldering iron. We're going to use rosin core solder once again. On this, we're going to heat right on the metal. It is a small area, so we'll heat right there. Leave just enough room to feed our solder in. There, it's starting to melt. And we want just a little solder, same thing, to coat that wire. It almost looks like it's a coating or frozen on there. Pull away, get another look. Remember, you want the solder throughout, so I'm heating on the bottom of the connector, pulling it throughout, and it looks like we have a good solder joint there. I'll hold it up so you can see what we have here. Looks like it did before, but now it's just a slight coating of silver. We can still see strands of the wire, but it's connected between the wire and the connector, giving a good low resistance connection like we would need on electronic circuits. Our final step with this would be to crimp the back ears. Now, some terminals will use a weather packed, like rubber seal. You would actually slide that onto the wire first. You'd slide that in place now, and those back ears would wrap around holding that in place. That would seal the plug cavity. Some might not use that, so then you would just put those ears around the wire. Select, we have two to choose from here, either the smaller or larger. We'll try the smaller one. We're going to put that in place. If those ears don't fit in there, feel free to pinch them shut a little using the nose of the tool. Put that in. And now we'll crimp it down, which wrap them firmly around the insulation. You can see what we have there. So that completes we did our soldering and heat shrink. We did a solderless connector, and we did a OEM style connector, which we said might be something like Metripack like this, WeatherPack, or others. Don't forget to try this out. Don't forget to try and insert the pin. Make sure it would go in all the way with the respective pin. That soldering isn't blocking the hole and the wire doesn't stick in too far. This one does seat fully, so that confirms this is good. Once this project is done, you're going to want to put your name on it. Just wrap a piece of masking tape around on it, write your name, and hand it in to your instructor to be evaluated. Do remember, we will be pulling on these, so test it yourself first. If it pulls off, you need to do that crimp again. Thank you.